And the three major components, again, there are 4/4 roots of 16. As you would hopefully suspect, there are 4/4 roots. We're looking at 16. 16 is a constant, which I'm going to refer, in looking at the equation, the relatable equation that is, that we saw when we first discussed the fundamental theorem of algebra, x to the fourth is equal to that constant, 16. Now think about that for a second. If I had asked you to solve for x, again, back to Algebra 2 pre-calc, you would simply think, okay, well, if I take the fourth root of both sides, I'll end up with my fourth roots, and I say roots plural, plus or minus 2. Well, that's only 2 out of 4. There's 2 more. All right, there's 2 imaginaries left. Okay, and that really hopefully should, put a little question mark here, should remind us all, okay, we've got more work to do. But again, thanks to the fundamental theorem of algebra, there are a total of 4. There's a plus 2, minus 2, and then 2 imaginaries which we don't know. So again, as we relate this now to this new property from up above, or formula, we've got several things to calculate, all of which are easily identifiable, particularly with, well, 16. What I'll ask all of us to first identify, it is a constant, like I said, but it is a constant specifically relatable to a plus bi. As a matter of fact, 16 plus 0i is what I want you to consider, which in turn, you can think of the ordered pair, 16 comma 0. And that's something you can go straight to the real and imaginary axis with, graphically speaking. We'll do a smaller version of which here, where 16 comma 0, a comma b, the r value 16. And, well, I'll tell you what, that's a very easy analysis, not just with r, but with theta. So as we continue this process, however, we're going to have to do our calculation using not only r, not only theta, but n, which in this case is 4. How do I know it's 4? Well, it's to the 4th power. Relating back again to the nth root. In this case, the nth root of the r value. Let's write our r value, maybe here. Okay. So yeah, let's start the ball rolling once again here with this new formula. We've got the nth root of r. So we'll start with, well, I'm going to start you off with k equal to 0. We're going to actually graduate our way up with k equals 0, then 1, 2, and then we're going to finish up with k equals 3. I'll explain as we get through this here what I mean by that. So again, the nth root of r, so nth root of r, 4th root of 16. Let me correct that. This is 16 as we know. So if you multiply that by the cosine of our theta value, now let me highlight theta here, as we can just simply see from the graphical depiction. I'm not going anywhere. My theta value is just 0. You can call it 0 radians, you can call it 0 degrees. In this instance, I'm going to use radians simply because, well, the formula does call for 2 pi. Could you use 360? Sure. But we'll stick to using 2 pi and 360, 0 degrees. Those values can be related. So the cosine, again, of 0 plus 2 pi times, okay, so this is where we're going to go ahead and start plugging in this particular part of the formula, the k value. K is going to start off to be 0, all over n. Again, n is 4. Plus I times the sine of the same thing. Okay. And this can be calculated, each particular quantity that we see here. So we have 0 plus 2 pi times 0, which is 0. 0 divided by 4. So this whole thing is just simply 0, as is this. It's the same exact quantity. And then we go ahead, using our unit circle once again, we can identify the cosine of 0 and the sine of 0 pretty simply. Let me take the 4 through to 16 again. Well, we already did that back there, so 2. And I'm not going to put plus or minus in front. We're not solving as we did back in this equation. We were solving for x, as you all remember from Algebra 2 and pre-calc. We actually need to include plus or minus with an even root. We're not solving here. We're just coming up with the roots. All right, so 2, it's positive times the quantity. Okay, so the cosine of 0 radians. Well, cosine of 0 is 1. Sine of 0 is 0. So we have 0 times I. We do our math, in other words, distribute. We get 2 times 1, 2. 2 times 0i, well, that's just 0. So the first fourth root of 16 is 2. And gosh, we already knew that. Let's move our way up to k equals 1. The process repeats itself, but, well, as you'll see here, some nuances will be discovered with the 4 through to 16 now, times the cosine of, yet again, 0, plus 2 pi times 1 now, all over 4, plus I times the sine of the same thing. All right. So we write that out. Doing the math inside the quantity again, we've got 0 plus 2 pi, or just 2 pi in the numerator, all over 4, which is pi over 2, and again, pi over 2. We can again reflect upon the unit circle. This is 2, first of all. Cosine of pi over 2, that's easy enough, that's 0. Sine of pi over 2, that's easy enough, that's 1. Okay, so we do the math yet again. And distributing, we end up with 2 times 0 is 0, 2 times 1i, or just 2i. So that second root actually ends up to be an imaginary. And again, we know that there's 2 imaginaries, so we've got 2 left. We hope to get negative 2, and we hope to get another imaginary here. Let's continue. K equals 2 now. So we set up our formula, the 4 through to 16 again, times the quantity cosine 0 plus 2 pi times 2 all over 4 plus I times the sine of the same thing. We'll do our math, and the quantity yet again with 2 pi times 2 is 4 pi plus 0, well, just 4 pi over 4 pi. And this again, pi. All right, so we'll go ahead and continue with the calculation. 4 through to 16 is 2. Cosine of pi, negative 1. Sine of pi, we've got 0. Again, unit circle comes up. Once again, 2 times negative 1 is negative 2. 2 times 0i, or just 0. So yes, negative 2 is the third root as anticipated. Let's find that fourth and final root. Now notice our k value is 3. It's not 4 for the fourth root, it's 3. Because what was the k value we started with? Well, we started with 0. So 4th root of 16 times the cosine of 0 plus 2 pi times 3 all over 4 plus I times the sine of the same thing. For the sake of space, I'm just going to go ahead and simplify this. 2 pi times 3 is 6 pi, and then divide that by 4. You've simply got 3 pi over 2, and this is 3 pi over 2. So we can go ahead and simplify in the next instance with, well, 4th root of 16 is 2 again. And then we've got cosine of 3 pi over 2, which we all know to be 0 from the unit circle, and the sine of 3 pi over 2 to be negative 1. Distribute the 2, and we end up with 2 times 0, which is 0, 2 times negative I, so negative 2i. Okay. And because of what we started with, the fact that it was a nice, just simple constant, taking the fourth root of that constant, we did end up with plus or minus 2, easy enough. And then the two imaginaries end up being complex conjugates of one another. Now this is not always going to happen with a problem like this, but this is something that, as we saw back in Algebra 2 and Pre-Calc, could happen. Let's move on to the next example. Example 7. Find the 3/3 roots of 4 root 3 minus 4i. So the first step that I'd again like you all to take a look at is rewrite this particular a plus bi form as an ordered pair. Again, there's a and there's b. So I'm asking you for 3/3 roots of this complex number. So we do need to consider, just like we did in the last problem, graphically speaking, given the real and imaginary axis, what we're looking at. We are in fact looking at 4 root 3 comma negative 4, so it is a fourth quadrant angle. Let's do a calculation on this. So 4 root 3 as a decimal, 6.93. So 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. 6.93 is roughly here, and then comma negative 4. So this is the representation of this complex number, and we do need to find our r value. We do need to find theta. There's several things we need to come up with. We do know n. Okay. All right, so let's go ahead and label that theta. I'm going to get the process going here again with r, finding the square root of the a squared plus b squared, and that ends up, if we do the math appropriately here, square root. I actually still have this on my calculator, so I might as well just do this. Put the answer, hit second negative button, as we all know, quantity squared, and then negative 4 quantity squared. Well, why not just type that in as 16? So what's our radius? Well, our r value is 8, or hypotenuse. Okay, so that is good. As I already indicated, n, we do know it actually ends up being simply 3. So we are going to find 3/3 roots, given, again, the original value here to be in the fourth quadrant. A couple more things before I can completely get the formula going. I'm going to take the tangent of theta, set that equal to opposite over adjacent, or b over a. And again, how did I know b over a was what I needed to utilize? Well, we know that if we were to drop an altitude here, we've got negative 4, we've got 4 root 3. So yes, opposite over adjacent is what the tangent of theta is equal to. Okay, an analysis of this fraction here gives us negative 1 over root 3, or if we simplify that, simply negative root 3 over 3. Let's take the inverse tangent of negative root 3 over 3. And if we're in degree mode, it'll probably make our lives easier. So, negative 30 degrees. And that is a nice angle, as we may or may not have anticipated. We have seen this ratio before, so we do in fact get a theta value of, again, negative 30 degrees. So that just tells us what the reference angle right here happens to be. Okay.